I welcome you all to the Spark Research YouTube channel. This is Dr. V. Chandra, Assistant Professor in the Department of ECE, and here we are going to take some more questions which has already been asked in GATE 2022 from this particular course, that is Analog and Digital Communication course. And we will take the particularly questions which is related to the analog and digital analog communication, particularly the amplitude communication, that is the unit first and second, right? So here is the overview, and if you will check the gate series, then always they are asking at least one or two questions definitely from this amplitude and the angle modulation techniques, right? So let's take some questions. So question number 42, what is that question? For the modulated xt signal is equal to mt cos omega ct, the message signal mt is given 4 cos omega ct, and the carrier frequency is fc is given, that is 1 megahertz. The signal xt is passed through a demodulator, right? So this is the one of the demodulator as shown in figure. The output yt of the demodulator is asking what will be, right? So question is that there is a xt here, and there is a one local oscillator, and local oscillator is generating the frequency of fc plus 40. Fc is given 1 megahertz, means this is something like that carrier wave, but not exactly the carrier wave. This frequency is because generating the carrier wave with the offset frequency of 40 hertz, right? And so now after demodulator, here is your demodulator output. We are passing it through a one low pass filter. So what will be the output? This is the question. So final answer is definitely the massive signal, but let's check the what will be the frequency of our exactly output. So as per answer key, your answer should be your B, that is cos 920 pi t. And so let's see the discussion. First of all, whenever we are going to the demodulations, you should know some basic concepts. So how can we demodulate these type of signals? So these type of signals can be written like E of t, that is error of t, and which is equal to mt and cos square omega ct. Why is this cos square omega ct? Because your modulated signal is mt cos omega ct, and we are multiplying cos omega another cos omega ct, which is the local oscillator. But here your local oscillator is cos omega c and plus the 40, right? So we will just replace that value, so same process, and then we are converting this equation into the frequency domain, and there we are finding the band, the band diagram. So this is the band diagram for your E of t. So here is your mt cos omega ct, this is the local oscillator carrier frequency, and then E of t, that is the demodulator, and here is after the demodulated we will get the final message signal which will comes through this low pass filter, right? So this is the concept that you should remember. This will give you the exactly the idea, that is how are we solving this question. Okay, so here is the some details about this particular question. So signal, like how the signal is processing. So signal, massive signal is there, and this is the the multiplication, that is x of t, so mt and cos omega ct, and after multiplying the local oscillator, that is error of t, that is mt and cos omega square ct, right? Cos square omega ct, right? And so we will get this final s of t, and then after filtering out, actually why are we using filter? Because we will have the higher frequency in this error signal. So we will remove the all the frequency, and we will keep only the particular frequency which have the message information, so that always carries the message information with the lower frequency. So that is why we are using low pass filter. So finally we will get the output, right? So let's see the more details about these calculations. So first one, your message signal is given and having the frequency is equal to 500 hertz, then modulated signal, that is mt cos omega ct, and local oscillator should also be cos omega ct only, but here is the offset, right? So 40 plus. So no problem, we will multiply with this 2 in order to get the value of error signal, right? So let's find out. So first xt is your xt into xlo, that is local oscillator. So here we can get mt cos omega cos square omega ct. So instead of the cos square omega ct, this is your carrier and this is because of the local offset. So first we will multiply this cos and then we will multiply with the mt in order to find out the shifting in the frequency. So you can use this trigonometric identity, that is cos A into cos B is equal to half of cos A minus B plus cos A plus B. So first these two you can convert, and and then later you can put the value of mt. So this is mt is already given. Now if you will put, then you will get twice of cos 1000 pi t into cos of pi of t, and the plus twice of cos 1000 pi t plus this, using this equation, right? And now if you will see, so here what is happening, twice of fc. Twice of fc means what is the value of fc? In question already it has given the fc is 1 megahertz, and we are using the filter of only 500 510, right, hertz only. So it will carries the 1 megahertz, means automatically it will removed. So we will also not consider these frequencies, so let's consider this frequency only. Okay, so and that is the baseband also you can say. So we will consider this one, that is twice cos 1000 pi t and cos pi of t. Now again we will use this equation, that is cos a cos b, and we will convert back into this, right? So finally your equation will be cos of 1000 pi t minus 80 pi t and 1000 plus 80 pi t, right? So the subtraction, this will contains the 920 pi t, and the addition will be the 1080 pi t, 1080, right? So now if you finally if you convert into the frequency, that is this is omega is equal to twice pi f, then you will get the frequency 460, and another frequency, this frequency belongs to the 540. Since we are using the low pass filter having the cutoff frequency of 510 hertz, so what will happen, this since this carries the 540 hertz frequency, so automatically this will removed. So finally we'll have the only 460 hertz, right? Means what? Means the cos of 920. So this is the final answer, right? Okay, so let's take one more question. So in this question, SPMT and SFMT are defined below, are the phase modulated and the frequency modulated waveforms respectively, corresponding to the massive signal MT, right? So this is talking about the angle modulation. Here this equation belongs to the phase modulation, and this equation belongs to the frequency modulation, that is FM, right? So where Kp is the phase deviation constant in radians per volt and Kf is the frequency deviation constant in radian per second. If the highest instantaneous frequencies of SPMT and SFMT are same, then the value of the ratio of Kp by Kf is asking, right? So this is belongs to the phase modulation, and this equation belongs to the frequency modulation, and the highest instantaneous frequencies of both are same, it has already been given, right? So then what will be the ratio of Kp by Kf? So this is the simple question, and here your message signal is given, right? So message signal is varying in between 0 to 7, time is 0 to 7, and in amplitude it is varying from 0 to 10. If you will look here, then what is the maximum value of mt? Maximum value is 10, right? And okay, let's take the before going to talk about the instantaneous frequency, let's take the some idea about this, the frequency modulation and the phase modulation. So frequency modulation means this is the message signal and this is the carrier wave and this is the frequency signal. So here if you will see, then frequency of the carrier wave is varying with respect to the message signal. So this is called the frequency modulation, and you can also write your equation like here, your omega ct and plus this is the belongs to the message signal. So this is why the omega c will vary with respect to the message signal. Kfm is constant, right? So here, how can you find out the instantaneous frequency? So you can rewrite your, this is the instantaneous frequency. Theta t is equal to minus infinity to t and omega ct plus kf mf alpha into df alpha. With the help of this equation, we can find out the instantaneous frequency for this frequency modulation, right? And this is the final frequency modulated wave. Okay, similarly we can also find out the phase modulation frequency. Here is the phase modulation, message signal is here and here is the carrier frequency is here, and here again the phase modulation. The phase modulation, phase of your carrier wave will change with respect to the message signal, so that is why this is called the phase modulation. Now here, how can we write the instantaneous frequency? So instantaneous frequency we can write theta t is equal to omega ct plus kpmt. So this is the instantaneous frequency, and this is the final phase modulated wave, that is a cos omega ct plus kpmt. You may also rewrite like this, no problem. This is the same equations only, right? So in this manner we got. So once we will find out the instantaneous frequency for both phase and frequency, then we can equate, right, as per the question. So how can we find out the solution? So first we will find out the instantaneous frequency, that is fc and plus kp d of m. Now in this question it is asking the maximum value of the instantaneous frequency. So when will it be the maximum? So maximum will be when so the d of the theta divided by the dt is equal to 0. So that in that case it will be the maximum. So let's take the differentiation of this d of mt divided by dt with respect to dt. So at this only it will be maximum. For frequency modulation, since already integration is there, so if you will integrate, you will get this kpmt, and for this kpmt kfmt, and for phase modulation, it was theta and plus kpmt. So we will get the differentiation, that is kp dm by dt, right? And so that we have to find out the dm by dt. So we can get the dm by dt from this particular image, since it has given that your what is the maximum value of dm by dt. So this curve is showing the highest slope, so you can find the slope in between 1 and 3. So how can we find? So we can find y2 minus y1 divided by x2 minus x1, right? So y2 is suppose 10 and y1 is 0, and divided by x2, that is 3, and x1, that is 1. So we can get this slope, that is dm by dt, right? And maximum value is already given, right? Maximum of mt is how much? 10. So we'll use these values in order to find out the values, and after that we can equate and we will get the value of kp by kf, right? So this is the procedure. Let's see the final calculations here. So here is the phase modulated, the instantaneous frequency, that is 1000 pi t kp mt, and you can take the differentiation here. So we will write 500 plus kp by twice pi and dm by dt. This is the maximum possible instantaneous frequency in case of phase modulation. And for frequency modulation, since the differentiation of your integration is same, so 500 plus kf by twice pi and mt. So now we will equate this one and this one, right? So maximum value, first we will find out the dm by dt, that is maximum. So maximum value of a, that is mt is your 10, right? That is flat region. And maximum value of slope, that is we already got, dm by dt is like a change in the v, that is y2 y minus y1 and divided by x2 minus x1, so that is 5, right? So now we'll use, so now you can equate this maximum value of your frequency, instantaneous frequency, and maximum value of instantaneous phase. Now equate both of them, you will get the value, that is kp5 equal to kf into 10. So finally the ratio of kp by kf is equal to 2. So this is the final answer, right? So that's all in this session. Thank you to join. If you have any doubts, drop your comments. Thank you.